All right, so the beginning of this lesson we talked about measures of center, mean, median, mode. For this next portion of lesson 11.1, we're going to talk about measures of variation. So two of them that we're going to discuss in this lesson are range and standard deviation. Now I imagine you already understand what range is. Let's just talk about what that is, okay? And then that'll get into why they're called measures of variation. So in number 3, it says the heights of the members of two girls basketball teams are shown. Find the range of the heights for each team. Compare your results. Now this is different than range, like when we just finished all of our algebra graphing in terms of like domain and range. This is different. So the range of data is how much it spans. So if we look here, the shortest person on this team is 48 inches tall. And the tallest person on this team is 78 inches tall. So to find the range, oops, I'm going to do 78 minus 48. Pretty easy. Okay, so the range is 30, and this is in inches, so the range is 30 inches, which transfers into 2.5 feet. So that means if we had like a lineup of the girls for their team pictures, well, the head wouldn't be bigger, but there would be a gap of 2.5 feet between the shortest and the tallest person if they were in line from shortest to tallest. So that's the range of Team A. Now if they want us to go ahead and find the range of Team B, we're going to do exactly the same thing. I look for the shortest and the tallest person, the lowest and the highest values in my data set. The lowest one here is 49, the highest one is 70. So 70 minus 49, it's going to give me 21 inches, which translates into 1 foot 9 inches. Oh, that should just be foot, sorry. So just so you know, these symbols, like quotation marks, this represents inches, and this little line represents feet. Not that you really need to know that, but for good sake measure, if you're 5 feet 4 inches tall, it's sometimes written like that. Okay? All right, anyways, so the range here is 1 foot 9 inches, or 21 inches, if you just want to compare inches to inches. Okay? So then, if we wanted to compare the results, we would say that there is a larger range of data of heights with Team A as there is with Team B. So that gets us back up to what these are called, measures of variation. Variation in the sense that it measures how the data is distributed, how spread out is it, how is it related from within each of them. Okay, so that's range. That one's pretty easy. You just subtract the largest minus the smallest. Now standard deviation is something a little bit different, and there's this crazy formula here. We're going to do one of it, but I'm also going to show you a website on how you can, it'll calculate it for you. And we're going to talk about what it means. If we were in class, I would show you how to use it do it on our calculators. So it's like anything. It's important to understand what goes into it, but to do this by hand, you would not ever really do that by hand. Maybe, a few decades ago, yes, but not now. So anyways, standard deviation of a numerical set of data, it says right here, is the measure of how much a typical value in the data set differs from the mean. So it tells us basically if this is the mean, 5x bar, and it's 4, okay, then it tells me how far away all the data is from the mean. So it gives me a range, it gives me a idea of how that all works. So let me actually show you a quick website. This one right here. So there's a lot of these websites that explain things to you, and this one's actually pretty good. Okay, so I'm not going to get into all of the formulas for it, but it says here how spread out the numbers are. So let me do this so you can see it. So it's how spread out the numbers are. That's what this standard deviation is. Now if I scroll down a little bit, we'll get into all the other terminology and things like that, but I'm going to show you a good explanation. So here's an example. You and your friends have just measured the heights of your dog in millimeters. These are the heights. Okay, so if you wanted to find the standard deviation, first you find the mean, then you subtract each number from the mean. You're going to square that, and then you're going to take the square root of it. So that's what all this stuff is that they did. But here's why this is helpful. So the green line right here represents my mean. Now, whenever we find standard deviation, they did that whole formula, that big square root that we're going to take a look at in a moment. This standard deviation is 147. So they take the mean and they add 147 and subtract 147. And what they find is that most of the data falls within that range. Most dogs that they've taken a look at fall in that range, okay? Now the ones that are a little bit higher or lower are beyond that. So this is our standard, it's called standard deviation because we have a standard way of knowing what is normal and then also what is extra large or extra small in this case. Okay, and now what we're going to get into a little bit later is this thing called the normal distribution. So it goes up and down like this. And the thing I could relate this to is like if you go to the doctors, you have your well visits and they take a look at your height and your weight. Well, there is a standard, like if they look at all the children that have been, measured, they can do either look at everybody or they can just look at a sample of people, but they can use this standard deviation to figure out, well, what are most people? What's the average? And then they find a standard deviation and figure out above and below. And so if you're coming in at like really low on the height range, they're going to be able to see how far off the average that is. Okay, we're going to come to this normal curve later, but right now that's not our focus. It's just generally understanding what the standard deviation is and then going ahead and calculating it. Okay, we'll apply it a little bit. Alrighty, so let's go back to our notes. Let's do one. Okay, and you'll at least have an appreciation for how intense it is to calculate by hand. Alrighty, so back down here, I'm going to clear all this. So these are the steps that we're going to do to find a standard deviation. So I'm going to pick a few simple numbers. Okay, so let's go with, how about, let's say our data set only has 5 numbers. We have 1, 2, 3, 5, and 7. Okay, all right, so what I'm going to do first is I'm going to go ahead, step 1 says find the mean. So I'm going to find the average of all of these. 1 plus 2 plus 3 plus 5 plus 7 is 18, and then I'm going to divide that by 5, and I get 3.6. So my mean is 3.6. That's step 1. Step 2, find the deviation, how far away each data set is from the original number. So now I'm going to make myself like a little table. So this is going to be x minus the mean. Okay. Oops, sorry again. All right, so my first one is I'm going to take x, which is 1, minus 3.6, and I'm going to get negative 2.6. Okay, then I'm going to do 2 minus 3.6, and I'm going to get negative 1.6. Then I'm going to do 3 minus 3.6, and I'm going to get negative 0.6. Hopefully you're catching on. Then I'm going to do 5 minus 3.6. Each time I'm taking a data set minus the mean, okay, because that's what it says, x minus the mean. And I'm going to get 1.4. And then the next thing I'm going to do is 7 minus 3.6, and I'm going to get 3.4. Okay? All right. So now the next step, that's step 2, done. Step 3 says square each of these. So this I'm going to write as x minus x bar squared. This is step 3. So I'm going to do negative 2.6 squared. Now if you put that in your calculator and you don't put it in parentheses, you're going to get a negative number. But remember, a negative times the negative is positive. So make sure you put it in parentheses or just keep that in mind. 1.6, negative 1.6 times negative 1.6 is 2.56. Negative 0.6 times negative 0.6 is 0.36. 1.4 times 1.4, or 1.4 squared, is 1.96. And 3.4 squared is 11.56. All right, so that was step 3. We found the mean. Now, find the mean of the squared variations. So that's all this under here. Okay, so what that says is if I look at it, this is interesting to decode. This was each of these numbers squared. That's what we found right here. So they want me to find the mean of all of these numbers. So I'm going to add all of them up and divide by how many there are. So let's add these all up. Okay, so I'm going to add 6.75. I'm sorry, 6.76 plus 2.56 plus 0.36 plus 1.96 plus 11.56. I'm going to add each of those numbers up and I'm going to see what I get. And when I add them all up, just making sure I did them right, I get 23.2. Okay, now I have to divide them by how many I had. So we think about it, the mean is when you add them all up and you divide by how many you have. Well, I have 5 numbers here, so I'm going to divide this by 5. And I'm going to get 4.64. So all this stuff in here is the same as 4.64. And that's where it says here, this number underneath is called the variance. Okay, just for reference of, now the very last step, that was step 4. Last step is to take the square root of all of it. So I'm going to take the square root of 4.64, and I get the square root of all of this is 2.15. Whew. Okay, so what that means is each data number is about 2.15 values away from the mean, which we know the mean is 3.6. Okay, so it's not exactly that much, but that's on average, that's what we've calculated. So here's what I want you to get out of all this. This is long. I totally respect that. And if you were watching all that saying, whoa, I thought this was going to be an easy chapter, it is going to be easy, especially easier. But I wanted you to understand where it came from. And that's why we only picked a small data set. Now, if you were thinking, think about something big. I don't know, like I said, heights of people, of students aged 14 when they go to their well visit. You know, they're looking at a wide range of data. You are not going to sit by hand and do this. Easy to make a mistake and would take so long. So let's talk about some shortcuts. Okay, we're going to skip this for the moment. We're going to take a look right here. Okay, find the standard deviation of the heights of team A, of team B, and then compare them. All right, so what I've done is I've gone online, and you can just Google standard deviation calculator. This is not the only one. I Googled it, and this is what came up. Okay, so if I want to do the standard deviation calculator, I'm going to go ahead and I'm going to type in, let's refresh it. I want a new one. So there we go. All right, and this one, they asked me to type in all of the data points. So they asked me to do this in this problem for teams A and team B. I'm going to do team, I think I already have them in there for team B, 49, 50, 70, blah, 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 blah. Let's see, I have 49, 50, 70, yeah. So I have all of team B's in here. And they asked me to separate it by a comma. I hit calculate, and look how fast everything we just did is done. They even kind of break it up for us. They say there's 10 numbers in there. They find the sum of all of those. They take the mean. They found out what the mean is, the variance. They took the square root of 41.25, all that stuff. All we need to know, though, is at the end, there is my standard deviation. Okay, and they tell us that right up above. So if they want me to find the standard deviation, I can say that it is 6.42. Okay, you could get more specific, 6.4226. Let's write that down. So in this problem, that was team B we were doing. So I'm going to write down, now the symbol for standard deviation is this, it's called sigma. It's a Greek letter. So it's 6.4226. Okay, now I did that already for team A, and the standard deviation here is 8.6977. So whenever they ask me, so what this means is that the heights of team A people are about 8.69, I think that was in inches, away from the mean. And then for team B, it's about 6.42 inches away from the mean. That's how the data is distributed. Now compare them with that. What I can conclude is that team A has a wider range of heights. There's more spread out. I can say that team A, their heights are more spread out than team B. Now, if I would look back at team A and B, that made sense. They were more spread out. There was a wider mean there, okay? Or a wider range from the top to the bottom, the tallest to the shortest person. So that's just a brief look at standard deviation. If you need to calculate it, you can try it by hand. If it's a small data set, you are welcome to check it with the website. But in terms of interpreting it, the larger the number, the more spread out the data. The smaller your standard deviation, the more collected, the more close-knit the data is. Okay? Alrighty. Let's go ahead and see the only little bit that's left. Okay? So the last